Alright, in example 1, they want me to use the table of values below to sketch the differentiable continuous function on the grid. So we've got a number of ordered pairs here from this t-table, and let me take a minute and I will plot these ordered pairs, and then we'll see if we can sketch a smooth curve through it. Alright, so I've sketched my ordered pairs from the table, and the next thing that I'll need to do is to try to sketch a smooth curve through these points. So give me just a second and I will see if we can get something passable. I think this might be serviceable. Alright, let's see what we can do. Alright, so in part A they want me to find the average rate of change of g of x on the interval from 2 to 9. That's a closed interval. So we're going to use our average rate of change formula. So average rate of change is equal to, remember that was f of b, so that's f of 9, minus f of a, which that's going to be f of 2, over b minus a, that's 9 minus 2. And if we take a quick look back at our table, f of 9 is, let's see, 11, and f of 2 is 4. So that's going to give us 11 minus 4 on top, 9 minus 2 on the bottom. 11 minus 4 is 7, 9 minus 2 is 7, and so we have an average rate of change, or a slope, for the secant line passing through 2, 9 as 1. So next, they want me to see if g prime of 6 is equal to the slope of the secant line from part A and provide a justification. Well, alright, let's go to the drawing. So let's take a minute and sketch that secant line in. So I'm going to change my color to blue, and let's label these points 2, 4, and what was it, 9, 11. Alright. So I'm going to need a straight edge. Alright, so we have our slope of the secant line is indeed 1, and so our graph of the secant line verifies our calculation for the average rate of change. So the question is, what is the slope at this point? 6. So let's do the same process. Let's take our straight edge and let's just sketch a tangent line at that point. This gives us a tangent line, and they do not have the same slope. This one looks like it's 1, 2, 3, 1, 2. Maybe the slope is equal to 3/2. And that's compared to our slope of 1 for the secant line. So let's go back and see. And our justification is that g prime of 6 is equal to 3/2. And that's average rate of change was equal to 1 from part A. So g prime of 6 is not equal to 1. So the next question is whether or not Rolle's theorem will apply on the interval 4, 9. Let's go back and take a look. So on the interval from 4 to 9, it is continuous, it is differentiable, but the question is because remember that third criterion for Rolle's theorem was that f of b is equal to f of a. Well, f of 4 is not equal to f of 9. So, no, f of 4 is not equal to f of 9. So we can't make use of Rolle's theorem. Alternatively, from part A, the average rate of change was equal to 1. It was not equal to 0. So definitely not. Let's look at part D. Is there another interval where Rolle's theorem applies? Well, let's take a look at it. Alright, now rather than kill myself looking for points on my graph, a real fast way to do this is to go back to the table, and I'm looking for y values, g of x values that are the same. In other words, where g of a is equal to g of b. I see 2 right now. Here is 8, and there is an 8. So on the interval from 4 to 11, so yes, so let's say 4 to 11, and let me change colors. Do we see any more? Oh, here's another 8. So we could say maybe from 11 to 15. All right, and these need to be closed intervals. All right, and so this gives us a very good application of at least finding the criteria for Rolle's theorem and whether or not we can use it on a graph that we have sketched ourselves.